Hello everyone. So in this video, we are going to discuss about backpropagation. There are some prerequisites for this idea. The first one is that I hope that you already understand about what is training data and how a neural network works. Now for this, uh, the second prerequisite, I have explained it before in this video, so I suggest that you watch this video before you watch this current video. So let's dive in. The first question will be, what is backpropagation? Well, simply it is just a method to train a neural network, and we should train a neural network because we want to create an accurate prediction and classification. So that's what is backpropagation and why we should do backpropagation. Now, the main question will be, how do we train a neural network? Well, we have to adjust the weights of the neural network's link and the biases of the neural network's neurons. Now, just a quick review, what is weights and biases? Well, if we have a neuron, like so, this neuron will have, links, right? That uh, which are the one who will give the neuron inputs. Now, each link have their own weight. So this is W1, this is W2, this is W3. And of course, all these three weights are different from each other. Yeah, could be different from each other. As for the bias, it is neuron's responsibility. So yeah, and each neuron bias could be different. So this is weights and bias. Now, about training. Now, in order to adjust the weights and biases, we need a lot of training data. Now, a training data is consist by two data, which are input data and actual output data. And if we have n data and training data, it also means that we have an input data and input actual output data. Now, if I represent the input data as X and actual output data as Y, it also means that if we have n of those data, there will be n x, x1, x2, up to xn. The same goes for y, y1, y2, and up to yn. Now, this data is a list, and we could represent it as a vector. So vector x, this one is vector y. Now, training data is the most important material for to training a neural network, and we already assume that we know it, right? I mean, we already we have a training data. We have an abstract training data. This guy. Now, this is how the neural network works. Now, this is the first step of it. Well, at first, we have a neural network, and this neural network, of course, has weights and biases, and those weights and biases will be assigned randomly by random values, and then they got installed in the neural network. So to make it easier, I abstract it as a function. So it is a function named neural network. Well, I abstract it in Python syntax, like so, and then it receives an input, and it will produce a predicted output. Now, this predicted output, of course, will be so bad. will be so bad because it is random. The weight and biases are random. That's why it will be bad. Now, the input will be will be the training input data. So we insert the values of each input datum into the function. So we input x1 to the neural network function, and it will produce. Oh yeah. So I represent predicted output as P. All right. So P means predicted output. Now, if I insert x1, it will produce P1, and x2, P2, xn, of course, up to n, right? Like the last one will be xn, and it will produce Pn. And to make it and since we insert an input data, it will produce an output uh, and predicted output data, and we could just represent it in a vector. Now, as to make it simpler, I abstract it like this. So it you know it receives a factor of input training data, and it produces a factor of predicted output data. Now this is the first step, which is to find the predicted output. Now as for the second step, we have to find the error. Now, what does it mean? Well, first off, we have to take the p, the factor p, which are this one, to the second step, along with the actual output data, or y, factor y, to the second step. And then we compare both of them. So as you know already, the actual output data should be the ideal output data, while the predicted output data is our current uh, neural network ability. So we compare those two results. No, no, not those two results, but those two data. Like so, we compare them, and after we compare them, we will get an error, a difference between those two data. Now this this difference between those two data is an error, right? In other words, it is an error. Now this error is actually a scalar, not a scalar, but a single value. So the input is a factor. The inputs are factors, but after we compare it, after we compare it, we will get a single value. So single value is just like simply one, or like it turns out like 10, like a scalar value. I don't know if it is right to say it like scalar, but it is just a single number. Yeah, just one single number. So this compare function is actually an algorithm, an error formula. So it could be a mean squared error, or it could be mean absolute error. And then you just have to choose when you want to implement it. But basically, it is just an error calculation formula. So another thing that I want to note is that this compare function also could be called as cost function. So the second step gives us the error, okay? The error here. Now, the third step is to adjust the weights and biases according to the error. So we bring the error to the third step, and then if we represent the weights as this factor weights, and also the bias as the biases as a factor of biases, like so. And then we adjust them. So we have a function named adjust, and then we insert w and bias and the b, and along with the error, the e. And then we after the function calculated, the function compares not compare but after the adjust function computes it, it will produce two values, which are uh, the b, the adjusted bias, and the adjusted weights according to the error. Now you see here we could just represent it as an old bias and old weights, and then we adjust it according to the error, and we got new bias and new weights, right? It is like the same idea here. Now, this function adjust here is one of the algorithm that could represent this function. This adjust function is gradient sense. And so we, after the third step, we got new biases and new weights that have been adjusted. Now, the fourth step is to install the new weights and biases to the old neural network. So we install the old neural network with the new biases and with the new weights and biases. So we insert them here like so. Yeah. And so we install them, and the result will be the new neural network with the new weights and the new biases. So this is the fourth step. We got new neural network which has new weights and new biases. Now, the fifth step is to repeat the whole process again. So you see, uh, after we got a new neural network here, we back again to the first step, which are you know, we insert the data, same input data to the new neural network. However, since the biases and the weights are different than the previous one, of course, the predicted output will be different. And then after we got the predicted output, we move to the second step, which is to compare the predicted output with the new with the actual output. Now we also get different. We should get different error than the previous step. Not the previous step, but the previous loop. But however, this error here ideally should be smaller than the previous loop. All right, so the error should be smaller than the previous loop because the weight and the weight and biases should be more better than just a random weight and biases, which is the first loop has. And so with the new error, which should be smaller than the previous loop, we adjust again the biases and the weights. So we adjust again. Now after we adjust them, we got new biases and weights. And we install it again to the neural network, to the old neural network, and we got the new neural network again. Now this loop will be repeated over and over and over again until the error here, until the error pass a certain threshold. So error should be smaller than a certain threshold, threshold, right? So for example, if the error is 0.09, while the threshold will be 0.1, then the loop, no, because it is like this, now the loop will breaks, right? So after the loop breaks, it means if the loop breaks, because the error is so smaller, is like very small, so we assume that the neural network is ready to classify or predict, uh you know yeah, it is ready to classify or to predict something. So that's how we train a neural network with backpropagation. I guess that's all from me. Thank you very much. Thank you so much for watching. Assalamualaikum warahmatullahi wabarakatuh.